I've just realised in the last one I wrote 310 instead of 315, so I'm just going to change it in this one. There we go. It's not going to annoy me. Now this has just got a wee bit about recognising trig functions. Most of the time it's type 1, which involves you changing your boundary. Okay, so following wave function, we're kind of looking for that. So that's sort of type 1, as I call it, wave function, and then bringing into type 1, change your boundary, work your way through it. What they can also ask you to do though is find the maximum minimum values. So once we have it in our form using our wave function, then we can clearly state what the maximum value is and what the minimum value is, following what k is, and then we can figure out where that lies with respect to your x. So we're going to work our way through it. What's the expansion this time? We've got cos x minus alpha. We are working in radians and it's non-calculator. I'll put alpha first, so it should be x first. I'll put my k in there as well. Jumping the gun here. Doesn't matter if you put it in there, to be honest, so as long as we've got it stated at the end here. Okay, let's match them off. Right, so sin x, where's my sin x? Is there. So root 3. Okay, cos x, we have our k there, our cos x there, and there's nothing there, so I'm going to be 1. No negatives this time. No negatives. Sines came first, so that's fine. Right, so what do we have? Root 3. You can see because it's non-calculator, we end up quite often getting the same thing. So we know that's 2. We've done millions. I've done millions by now. Alpha. Following it, what we got here. So k sine alpha is root 3. K cos alpha is 1. Cancel them out, and then obviously we know that that's the same as tan alpha is root 3. Everything's positive. Which is 60 degrees, but we are working in radians and there's nothing we need to do with it, so I'm just going to go to radians, pi over 3. So therefore, what's our answer? We have 2, just above there we can see it, x minus pi over 3. Okay, and that is our answer. So because it's asking to leave your answer in radians, we have to do it at this stage. Right, part B. So hence find for that the maximum minimum values, minimum turning points of that, and the points of intersection. Now the key for this, in my opinion, is really thinking about your graph. Okay, you can solve it algebraically, or you can think about your graph. For me, I think the graph is always easier, and the maximum minimum value is dead easy to get as well. So obviously straight away, we know the maximum is going to be at 2 and the minimum is going to be at negative 2. Now if we imagine what this graph looks like, what does x minus pi over 3 actually mean? So we know it goes up to 2 and it goes down to minus 2. We're working with cos. It's minus pi over 3, which means it starts over here. So if you imagine your cos graph, it's going to be something like this. 2 minus 2. Now for the purposes, let's think about it in degrees. Okay, so that's 60. Now, always think about what do we know about an actual cos graph. 1 minus 1. We know obviously that's at 90. We know that that's at 180. If we think about the coordinates, negative 1 is the minimum. We know that's 270, 0, and obviously we know that's 361. Okay, so what's changed here? Well, we've moved everything 60 degrees. So all we want to know is maximum, minimum, and we're only going up to 2 pi. Now 2 pi, if you think about it, 360, because you've moved it over, that's actually going to end at 420, so 360 is like in there. So our maximum is here, and our minimum is here. So what do we know? Right, maximum. So we know it is something 2. Okay, where is it normally? Your maximum normally technically would be here. It's there, it's 60 degrees. Okay, 60 degrees over. Your minimum turning point we know is something negative 2. Normally it's 180. We know we've moved that way 60 degrees. Plus your 180 is 240. Now we need to put them in terms of radians. So in terms of radians, we're going to have pi over 3, 2. Now 240, again, how many pi over 3s? We're going to have, you can think of it like 8 pi over 3. No, that's nonsense. 4 pi over 3. How do we get from that to that? Times by 4. 4 pi over 3, negative 2. So these are your two answers. So really think about what's changed about the graph is the best way to think about it. Cos graph, what does this graph look like? And figure it out that way. Do the same with the points of intersection. So the points of intersections, again, I'm just going to redraw it. Okay, normal cos graph. We know points of intersections are at 90 and 270. What do we know about the graph? We know it's moved that way 60 degrees. So these two are going to be that way 60. So they're going to be at 150 and they're going to be at 330 because I've added on 60 to those two. So therefore, point of intersection with the x-axis are going to be, again, I'm going to put it as degrees first. We know we're working with pi over 3, so how many is that? 5 pi over 3 and 11 pi over 3. Okay, so that's our first two. Second one we need to know is where it cuts the y-axis. Okay, where does something cut the y-axis? It cuts the y-axis when x is 0. So we've got our graph, remember, which is this. Okay, so we have y equals 2 cos of 0 minus, again, I'm going to work in degrees because it's easier. Okay, cos of negative 60. Now again, you want to know is it the same as the positive or the negative of 60. Now if we draw a cos graph, I'll make it a bit neater. Okay, and we think about, well, if we extend it back the way, okay, where's 60? It's going to be in like there. So it's the same as the positive of it. Cos of 60 is 1, using your exact values. So it cuts the y-axis at 0, 2. So by using your graph and a wee bit of manipulation as to, okay, what does this actually mean? What does x minus pi over 3 or x minus 60 degrees, what does that actually mean? It means that your graph obviously has been moved 60 degrees to the right. So you're thinking about what's happened. Okay, it used to be 90, now 150, it used to be 270. And you're, what? Wait a minute. Cos of 60 is a half, not 1. Nonsense. That's 1. There we go. So think about the graph, think about what does 2 cos x minus 60 degrees pi over 3 look like, and then from that you're kind of figuring out what's basically changed about it. Okay, there is a way you can solve it algebraically, but which your teacher will show you, but I think it's much easier just to think about what does the graph look like.